This next lesson should be something very new and very different. I'm not sure that any of you have really done any work with trigonometric ratios. So it's going to be kind of extensive, but hopefully we'll get it explained well enough where you understand. So the first thing that we need to know is what is a trigonometric ratio. And this is the ratio of the lengths of the sides of a right triangle. Again, this is something like Pythagorean theorem that only works with a right triangle. And this is going to be related to the acute angles. So everything is going to be based on which acute angle we are talking about. So what I want you to write kind of in this blank space that's left is going to be kind of a weird word, but it's SOHCAHTOA. S-O-H, so, K-A-H, and then TOA, T-O-A. So when I was in high school, I had a teacher that helped me remember this by saying, some old hippie caught another hippie tripping on acid. So maybe that'll help you guys remember it, but if not, just try to remember SOHCAHTOA. And what this is kind of a description of the three most common ratios. You've got sine, cosine, and tangent. Sine is usually abbreviated with sin, but it's actually sine. And then cosine is usually abbreviated with COS or cos. And then tangent is usually abbreviated with just tan. And these are the buttons that you've probably seen on your calculator, but not really known what to do with them. So again, let's kind of see if we can use just basic information, and everything is going to be based on this triangle up here. So it says, what is the sine of A? Well, if we go off of, and I'm going to write it down here so we can kind of reference it. Sine of A, the abbreviation we already said would be sine or sin, A. So that's the sine of A. And then by definition, sine is going to be O for opposite, H for hypotenuse. So this is going to be the opposite side over the hypotenuse. And again, this all stems from A. So if we look at this side right here, here is angle A. The side opposite is going to be labeled the same letter right now. So this A is the opposite side. Adjacent is going to be the only side left that's not the hypotenuse. So that would be this one. Remember, adjacent just means side by side. And then obviously the hypotenuse, no matter what, is always across from the 90-degree angle, which is C. So in this case, the sine of A, the opposite side is A, the hypotenuse is C. Then we have cosine of A. So again, the abbreviation is COS and A. And according to our definition, co, or cosine, is going to be the adjacent over the hypotenuse. So again, I'm going to start with A, but now I'm going to go to the adjacent side. So the one that's right beside it, but that is not the hypotenuse. So B over C. And then we have tangent of A. So there's our abbreviation. And then tangent is going to be opposite over adjacent. So from A, again, this is where we're starting, is angle A. The opposite side is A. The adjacent side from A is B. So this would be A over B. Good. So at the bottom, you see if you can do the sine of B, the sine or cosine of B, and the tangent of B, and see what you come up with. Okay, remember the definitions aren't going to change. So flip it over on the back, and now we're going to try to do the same thing, but now using numbers. So hopefully you didn't have any problems finding the cosine of B. So it says find the sine of L, the cosine of L, the tangent of L, the sine of M, the cosine of M, and the tangent of M. Express your answers in both fraction and decimal form. Round your decimals to the nearest hundredth. And remember, hundredth means 2 decimals. So in case you need it, we can go ahead and write SOHCAHTOA. Some old hippie caught another hippie tripping on acid. So SOHCAHTOA. So if I wanted to find the sine of L, remember sine is going to be the opposite over the hypotenuse. So opposite over the hypotenuse. So from L, the opposite side is 3, so I would put 3. And the hypotenuse is always across from the 90, so that would be 5. So then if I got out my calculator and I divide 3 by 5, 3 divided by 5, it gives me 0.6. Since I'm supposed to have 2 decimals, I'm going to put 0.60. So now the cosine of L, cosine is adjacent over hypotenuse. So this is adjacent over hypotenuse. So from L, this is opposite. So 4 would be the adjacent side. So 4. And then the hypotenuse is still 5. So then to put it as a decimal, I just divide 4 divided by 5. And I get 0.8, and again I add a 0 to be a space holder. The last one is tangent. Again, remember tangent is opposite over adjacent. So opposite from L is 3, adjacent is 4, so this would be 3 over 4. And if I put that in my calculator, it comes out to 0.75. Good. So now you guys see if you can do M right here. Okay? If you have any trouble, make sure you ask questions. All right, at the bottom, we're going to kind of do a little bit of calculator work. If you do not have a calculator that does sine or cosine, on the very back of your paper, you should see, a chart, and you can use this, and I'll show you guys how, but I'm also going to show you how to use your calculator. So for these problems, it says, given an acute angle of a right triangle, any of the trig functions can be found using a table or a calculator. So here we're going to use a calculator to express each answer accurate to the 10,000ths. That means we should have 4 decimals. And that's what you're always going to use, which is why on your chart it goes to 4 decimals. So it says we want to find the sine of 42. Well, this is in degrees. So one thing that you've got to check on your calculator when you're using them is the mode. So on our calculators up here it says mode. If I push that, if you notice, the third line down is highlighted radians. We don't want to be in radians, we want to be in degrees. So I would push the over button, I would hit enter, and now it's in degrees. So I could do second quit, and if I went back to mode, notice it stayed in degrees. So now I can hit the sine of 42 degrees. So remember, your sine button is right here. So we would say sine, and then just type 42 and close your parentheses. Hit enter, and it says 0.6691306. Remember, we have to round to the 4th decimal place. So 1, 2, 3, 4. So then I look at the next number, 3. 3 is not big enough to make the 1 go up. So here I would get 0.6691 is equal to x. Now, how could I do that using the chart? Well, if you notice, there's a column that says sine of A, and then these are all the angle measures. So I would go all the way down to 42, and then the sine says 0.6691. So again, you can use the chart, or you can use your calculator. So then here, I would do the same thing, and I'd want to find the cosine of 62. So I would hit cosine 62, close, enter. Again, 4 decimals, so 1, 2, 3, 4. So I need to check, does 7 make 4 go up? Yes. So this would be 0.4695. So 0.4695. Good. So now you can do the tangent on your own. So now it says, what do we do if we're given the side measure of a right triangle and we're trying to find the angles? So what we're going to do now is we would go backwards. So we could look in the chart here, and we could try to look through all of these numbers and try to find 7, 2, 4, 5. Okay? It's not going to be the easiest thing to do, and trying to kind of narrow it down could be kind of difficult. So the easiest thing to do here is to use your calculator, again making sure that it is in degrees before you ever do anything. And what we're actually going to do is use the opposite. So notice right above sine, you should see sine inverse, meaning we want to go backwards. Right above cosine is cosine inverse, and right above tangent is tangent inverse. So down here, when I'm trying to find what angle measure would give me 0.7245, I'm actually going to do the sine inverse of 0.7245. So in your calculator, we do second sine, and then I put in 0.7245, close, hit enter. And notice we wouldn't have ever found it in our chart because it's actually a decimal. So we're going to go ahead and do just 2 decimal places, since it does, oh it does, sorry, to the nearest tenth. So that's 1 decimal. So since this came out to 46.42, here's 1 decimal. The 2 doesn't make the 4 go up. So this would be 46.4 degrees. And if you weren't sure if you're right, you could try it. Sine of 46.4, and there's your 0.7241. Okay, so we didn't really use enough decimals to get to the 5, but you got close. So then, same thing, this time I'm going to go ahead and do tangent and let you do cosine. So here, we would do the tangent inverse of 0.4279. So second tangent, and then 0.4279, close. We get 23.16. So the 6 makes the 1 go up. So this would be 23.2 degrees. Good. So now you can try to do the cosine. So far, so good. All right. So let's look at the next sheet. It says, consider this right triangle below. what is the length of the side that is adjacent to 25 degrees? So if we're looking at the 25, remember this is opposite, this is adjacent, and then the hypotenuse is always across from here. So if we need to label them, we could. This is the hypotenuse. This would be opposite. This would be adjacent. So it says, what is the length of the side that's adjacent to 25? Well, that would be just x. What is the length of the hypotenuse? Well, the hypotenuse is 8. Which trigonometric ratio of 25 could be formed using the values given in parts A and B? So I had the adjacent side and the hypotenuse. Well, again, if we remember, SOHCAHTOA, so some old hippie caught another hippie tripping on acid. Adjacent and hypotenuse is which one? Right here. Adjacent, hypotenuse. So we would go ahead and say that we would use cosine, which is adjacent over hypotenuse. So now it says write a trigonometric ratio for 25 in terms of x and 8. So we know that the cosine of 25 would be equal to x, the adjacent side, over 8, the hypotenuse. So then part E says that they want us to use the calculator to find the values for that trigonometric ratio of 25. So what we actually are trying to do here is just find the value of x. So if I wanted to solve for x here, you guys have actually been doing it. This is cosine of 25, and it's actually over an invisible 1. And then this is x over 8. So if I cross multiply like we have been doing, this is actually 8 cosine 25, and that's equal to just x, because 1 times x is just x. So now this is considered multiplication. So I can actually put that directly in my calculator. 8 cosine 25. Notice it says 7.250. So I would now say that this is 7.25. Good. So now it says label the other leg of the right triangle y. So if I come back up here to my triangle and I now label this leg y, it says use a similar procedure to try to solve for y. So now I need to figure out which trigonometric ratio to use, because now I know y is what I'm looking for, and I know the hypotenuse. So from 25, I want opposite and hypotenuse. Well, that's OH, so I would use sine. So we would say that the sine of 25 equals, and again the opposite was y, the hypotenuse is 8. So now again, if I put this over 1 and cross multiply, I get 8 sine 25 equals y. So now plug that in your calculator and get your final answer. Good. So now let's explore just a little bit more. Now notice that they don't give me the angle measure, and they give us sides. So anytime that you're looking for angles, this is when you're going to have to use inverses, which again is your sine to the negative